Alright, video 3, and thankfully the final one in the series on equilibrium of a system of coplanar forces. And in this case we're into our second graphical solution using that wonderful new thing we've learnt, the resolution of a system of coplanar forces using the funicular polygon method. Now what I need for you to do this time is to refer to the second of the two problems from the notes we had a look at when we did the analytical ones in the first video, past the one with the nice simple stuff, so it's number 28 in the notes. And as we did when we looked at it in the analytical solutions, we spotted that there are some horizontal components sneaking in now because of the nature of these two angled forces as loadings. So when we did it analytically, we divided it up into its horizontal and vertical components, and we went through and calculated it out. But we're doing graphical solutions now. And this is where the graphical solutions become really handy. That last one, you might have said that seemed a bit long-winded, considering it was really easy to balance the other way. But now you don't have to do any of these calculations. So first thing I'm going to do though is do what I did before. Take your your space diagram and turn it into a free body diagram to scale. And here's one I prepared earlier. So there you go. And again, I've got a little bit of a line over there for me to work to. And we'll just talk through what we're going to be doing again. Funicular polygon method was to extend the lines of actions, and that's going to apply even though they're on an angle. Draw a force diagram to scale with the known forces. Then we're going to try and find where the other two forces might be in relation to a point using those strings, funicular, that we had in the other video before this one. So the first thing I did was extend the lines of actions. So we'll do that now again. Free body diagram has to be to scale. So the distances here, if I go back to the question that's being asked, 4 meters, 5 meters, 5 meters, 4, that has to be done to scale. So that's going to represent 4 meters, that represents 5, so there 5 and 5 and 4 and 4. It won't work unless you do that. So that's the first thing, it has to be to scale. In the exams, usually in the exams, particularly the HSC exams, unless it's otherwise stated, the drawing itself, the question that you might be provided is to scale. So I don't need to redraw that. I could just use the lines of actions on the drawing. That's another way you can save some time in the exam. I'll be showing you that some more in later videos and later classes because that's a practice thing. All right. So what I'm going to do now is extend the lines of action. When I drew this, I had to put them at the right angle. So you use a protractor to do that. That's 75 degrees, this is 160. I could use my 60 set square over here, but this one needs a protractor. Then you can put this one down, going straight down here. Again, making sure it's horizontal and put in the angle. And I've already done this before, so there's a little bit of help coming from some lines that you can't see. So I know that they're actually right. And finally, I'll put in the vertical one. But I'm not this time going to put one in on the other side. And I'll just talk to you about that one now. We've already discussed in the analytical solution that this is going to have a horizontal component. There is a vertical component and a horizontal component, which means that the resultant now is at an angle. The reaction is at an angle. We don't know exactly what it is, hence the squiggly line. We talked about that in video number 1. What I do know about it though, is no matter what the line of action is, because at this point I don't know. I know the line of action of that guy, I know the line of action of that guy, even over here I know, even though I don't know the value of it, I do know it goes straight up and down. But what I don't know is what angle does this go at? And as we need the lines of actions to do this funicular polygon method, am I stuck? Am I now in trouble because I don't have a line of action to work to? No, I'm not. And the reason is that no matter what line I put in, what angle, it's going to go through that point. I want you to think about that one carefully. No matter what angle it finally is, we'll work it out later. We'll find out what it really is in one hit, which is why this is better than the analytical solution for a fast solution. I don't know where it is, but I do know it passes through that point. So I'm going to use that point as my line of action. Now listen to what I just said. That's a line of action, that's a line of action. I'm going to use that point as my line of action when I start doing my funicular polygon, which means I have to start from that one. I'll come back to that in a moment. I have to start there because it's the one that I don't know the line of action about. Over here I've already drawn it in, so I'm just going to darken it in. What I've done here is drawn a scale of 1 centimetre is 2.5 kilonewtons, a little bit more difficult than the previous one, but nonetheless, just a scale. It's really not that hard to work with. That's going to represent, to scale, my 25. So that's the 25 over there. So we'll put 25 next to that so we know. Then coming down this way. Now, you don't have to put them in this order, by the way. I could put the 10 going back up and then come down with the 30. And it's still going to finish up here. Think that through. If I put the 10 next and bring it up here, then when I come down, it'll still come back to this point. It must. The value of those three forces are always going to, if I start there, it's always going to finish up down here at this point. That's just the principle about forces again, because the final two forces are going to be in the same relationship. However, if I go up there and across there, then I've got lines crossing over each other. So for the sake of making this polygon into an open space polygon, I've actually chosen to do the 30 next. Hopefully some of you can see why. You know, like you're going to say, oh yeah, that makes sense. If not, just remember it doesn't matter what order you put it in. As long as they're head to tail, or so head to tail, there's the tail, head, and so on. It's always going to work. And so that was the 30. So I've actually put the 30 in next. So I've jumped across and now I'm going to put the 10 going back up. They're my known forces. Right, so that's going back up. That's the 10. Didn't give myself enough room there for that one, did I? Okay. Now, last time we did this, we did a P, point P, somewhere out here somewhere. So I'm just going to put a dot there. That'll do. I can put it up here, I can put it down there. Remember in the first one I showed you, the simple one, doesn't make any difference where you put it. It's just going to change the angles, but the angles will all still work out because it has to. So really it's not important, just find a spot. One of the things though about them, if you make them nice and shallow, the angles are shallow, don't put it here, say, for example, because then you've got really steep angles and you might have to go off your page. Keeping it nice and low means that the angles are all going to be nice and low and they all tend to fit in the space you've got provided. So that's worth remembering simply because, you know, the more further out, the less angle, the more condensed this part of the diagram is. But if you happen to put it closer, you need to put it closer, it's fine, it doesn't matter. But here's what happens next. Let's look at this from the perspective of where are the forces that we've got. We know that RAV is vertical. We know it finishes up balancing out the whole process. So it's going to have some reaction to this. It's going to come back into this direction to cancel out the others. So, but this guy is actually helping out. So now we've got a little bit of an issue going on. Where does it go? We know it's line of action, and we know it's up. So we know it's going because we can tell from it's up. We've assumed it's up. We don't know it's up, but we assume it's up because that's a big 30 and that's a big 25. They're all going down. Even the component of that is going to be more than the 10. So it's pretty logical that both of these guys have got to go up because the resultant, even with the help of the 10, it's not going to cancel out all of that. So we still think it's going up, which is cool. And it looks like it will because it's got to get back up to here anyway. But we don't know how far. We don't know its size. We also don't know what angle the A is coming in at. So we know it finishes here, but we don't know what angle yet. We haven't worked that out. So we're going to put just an identity up here. We're going to take that's RAV. Oh, just RA actually. That's the end of RA because it's not actually the vertical component. And because this is only vertical, we can still call it RB or RBV, but that's reaction B. Oh, I just did that again, bumped the thing. All right. I'm just quickly checking we're still in view. I'll move it back a little bit. Yeah, there you go. Or I can move over. Easy. Sorry about that. Jiggling again. Now, what we need to do is find out where that goes, but we do know that it stops there. So that means that the RA is between the RA and the 25, the strings. So let's put those strings in. I did them in green before. Wasn't really trying to be clever or anything, but it helps make us aware of the difference between the strings and the forces. I probably shouldn't have done that closing string so boldly in black, either last one, so I'll probably do this one lighter. Okay, so there's one string coming in. Again, not very green. And that we'll call A, simply because it's the first one we've done. You don't have to call it A, you can call it Fred or George or Harry, as long as you don't mix them up. 1, 2, 3 is okay as well. But 1, 2 and 3 could be confused for values, so this is probably one of the reasons why they use B's. Or alphabet. There's your C, next one, and over here, I mean, if you're really clever and you knew your Latin, or at least your Greek alphabet or something, you could start putting in other sorts of forms and impress the examiners for whatever reason. Now, the final one, the closing string, is going to tell us how long B is and what the angle is. So we start by putting those back into the places we know. We know that this one goes from A, goes between the RA and the 25. Now we come back to the point I made earlier. Where is the line of action for RA? We don't know, so we take the point as the line of action. We do know it goes through there. So for this type of drawing, for this type of example of problem, where there are verticals and horizontals involved, I will need to start at the point rather than the line of action. And I might be able to get that to slide across all the way. Look at that, got it. Now, thankfully, the 25 is right next door, so we're starting right at that point, and we go across to the 25. All right, so that is A. 25 to A, so that's the one between it. Now, the next one is between the 25 and the 30. That's your 30 there. So the B is between the line of action of 25 and the line of action of the 30. So I'll line that one up. Now the line of action of 30 is coming towards me from over the other side because of the angle. So this could turn out to be a short distance too. Or is it going to slide? It's probably not going to slide from there, is it? Because I'm going to go away from it. All right, let's sneak up a bit. Get that lined up. All right, that should do it. Yep, get to there. That's where the other one finished. That's where the line of action of the 30 is. Put that one in. All right, that's B. Now the next thing is the C. The C is between the 30 and the 10. See, that's my C, between the 30 and the 10. So I'm going to get the C angle. Let's try this without bumping the legs of the tripod. There's the C, got the angle, coming across, and I start where the other one finished, where the B finished, and I've got to go to the 10, so this time I'm coming backwards on myself, which is fine. It all makes sense. All right, so that angle is the C, same as that over there. Right, I moved a little bit, but it should be right. Yep. That's where your inaccuracy is going to sneak in, isn't it? So let me just double check that one. It does look like it slid wrong. Come across, come across. Oh, gee, not by much. I'll fudge it for the next part. Fudge it, shouldn't do that. It's actually going to finish just slightly up there, but it'll wreck the look of the drawing. Okay, the next one is the D coming in. The D is going between the 10 and the RB. See, there's the end of 10, the start of RB, it's the top we don't know. So let's try and do this one better. What do we want to do? We want to get that 45, slide again, get it right, okay, slide up, and we're going from, I'm just going to get that dot a little bit higher where I knew the angle was wrong, so just get a bit of my accuracy back. Okay, so that is now the D line, that one there. Now, we started here, we finished there. The closing string, missing string, closing string, we talked about that last time. What you want to call it, I like closing string, other people like it missing string. I'll do it in a thin black this time rather than a thick black. There it is. So I'm going to use closing string this time. And that angle goes across to point P. Am I going to get there with that combination? Probably not. What I need to do is to maybe do it with this one. Will that make it? Yep, just got there. All right, so there's my line for C, sliding it along to the P, and this is where it goes, where it gets interesting. You're going right past everything over to here. There's the closing string. There. And it will cut the line of action of RB. And at the same time, we can do this one in, no, I won't do it in, let's do this in green so we can see them different. Should have brought 3 colours, should have a red one or something. Okay. That is the end of RB. That means this final piece going in there get it nice and dark for us, is RA. So that's reaction B and reaction A, including all the angle. So now if I go and use my scale to read off my scale, in this case I've got it measuring at 8.2, could be, again limit of reading, 8.2, and that's in centimetres. And this one here, I'm reading that as, looks like 8.4, maybe 4.5. I don't want to be that accurate, and I can't get directly over it because the camera's in the road. So again, we're looking at let's say 8.4 centimetres. Each one of those is 25, so I'd have to calculate out what it is. What was the original answer for this when we look at it? So we had calculated the moments for RB is 20. 8 times 2.5, 8 2.5 is going to give you 4 lots of 25, so that's 20. On the other side it was 21, slightly bigger. So there you go, not too far out. Close enough for my liking. You're going to be pretty right, again because the percentage wise. And now the angle. See the angle part we calculated here by doing all this stuff. All we need to do to get the angle is get our protractor if we've got one. Make sure you're reading off the vertical. And you're looking there at something in the order of 67 degrees. And what was the original one? 66.23. Little bit of inaccuracy because of the way, maybe even that part over here where I missed, could have brought it in. That might reduce that a fraction, bring the angle up a little bit further so you get less of an angle, but that's close. So you've got that at say 67 degrees. That's the force going up that way. You've got a size for it. You get it all straight off the diagram. So there you go. That is funicular polygon number 2. And again, looks fantastic. Have some fun with them. You can find a couple of those, things like that. Let's have a quick look at one of these, for example. You could do this one here. In fact, one of them says to do graphically. So question 13 is actually originally asking you to do it graphically. But if I did this just quickly with a pencil, show you the sort of thing you're going to be looking at. Line of action here. Over here, you know it's vertical. Why? Roller. Can't do anything else. Over here, we don't know, squiggly line. But we do know it passes through there. So if I was to draw the force diagram, I go down, there's only one force, 1 kilonewton, make a scale. You know the vertical one goes up, straight up, don't know how far, put a point P in, draw in line 1, line 2. You know that this one's the end of the RA, so that's coming from RA. So you take RA, take it parallel, take it down till you get the line of action, touch there. Then this one, it goes up to the line of action of B. So you go up to B. And you can do it on the diagram if it's to scale. So that's going up to be that one there, and that would mean that the final part comes in down here, closing string, take your closing string back onto your diagram here, runs down like that. That gives you the size of the first force and the angle and size of the second force, just by doing it that way. So there's RA and there's RB. Again, got to do it neat, got to do it practiced, and you'll be able to do them. Anyway, have a go. There's plenty of them to do. Keep you occupied for a while. Let me know how you go. Send me some copies, you know, make some, scan a few in, send them to me when you've got them, so I can check that you're actually on board with it all. Okay.